we're solving for x, and obviously it's an exponent, so we need to use logs. However, we have to look at this and say, well, these bases are not compatible. If I want a number for this, a decimal number for this, I need to use logs. Okay, and I'm going to have to use logs anyways, but to solve for this, I need to apply logs, and I have to decide, am I going to use base 3 and then the 10 doesn't work out nicely, or am I going to use base 10 and the 3 doesn't work out nicely? Okay, so we can do it either way. Just for our purposes, we can just use, we can use base 10. So what I'm going to do here is I'm just going to log both sides. If I log both sides, I can bring the exponent down. So it looks like this: log base 10 log base 10. Okay, well, this basically is an identity. Log base 10 of 10 is 1. And this, well, I'm not too sure what that is, but I know I can bring that exponent down and at least algebraically now solve for x. Okay, so although it's a log problem, bringing that exponent down lets me deal with that x as times and divide. Okay, so I can just do regular algebra to that. So this becomes 1, so I get x minus 2 equals 4 minus x log 3. Well, I'm going to rewrite this as 4 log 3 minus x log 3. And just remind myself, well, what's the whole point of this? I'm trying to get x by itself. That means I need to group my x's and put everything to the other side. So I'm going to get x plus x log 3, and then minus 2 becomes plus 2 plus 4 log 3. Okay. Well, I've now can algebraically, this is not logs anymore, really just algebra. I can factor, and then I can get rid of the 1 plus log 3 times with a divide. And then divide both sides. This is one solution. And like I said, with logs, there are actually multiple ways I could do this problem. Okay, so I've solved this as a base 10 log. Now, some of you may have said, well, I'm going to get rid of the 3 with a base 3 log. Okay, well, that's perfectly fine. Okay, so I'm going to log both sides. This time I get base 3 10 is equal to 4 minus x. Okay, so I've changed this into a base 3 log. Okay, well, I still have my x's. I've got x's that are on the outside, so I can treat them as regular algebra x's and solve for the x. So I'm going to again expand this bracket. I want to move that minus 2 log base 10 to the other side, and I'm going to bring that minus x to the left hand side with a plus x. So it looks like this: x plus x log base 3 of 10 is equal to 4 plus 2 log base 3 of 10. Okay, and then algebraically isolate the x. I'm going to factor. Okay, and then I can again divide. Again, I've got the x's outside the logs. I'm going to treat them as algebraic pieces. I'm going to treat the logs as times pieces. This is just, as long as I keep that all together, I can just treat that as one multiplication factor. And then I get this solution: 4 plus 2 log base 3 of 10 over 1 plus log base 3 of 10. Okay, and this solution is the same as this one, although again it looks different. Okay, these are perfectly good solutions. Now, if I really want to, I can convert one into the other. I can change this base to base 10, and I can multiply through with log base 10. Okay, and I can get rid of these denominators. I can get this to look the same. Okay, so this is the same solution as the solution I have here. Okay, they look slightly different, but numerically they're the same. Okay, and they're perfectly valid solutions.